welcome back. Hope you are excited to continue with me on this wonderful journey as we look at additional mathematics. My name is Nana Yawedu and you can call me Say Nana. Remember to subscribe to my YouTube channel so that you can receive every video on time. In our previous lesson, we have looked at an example of the commutative property of operation and a binary operation. We've been able to determine whether or not an operation is commutative or not. In this lesson in binary operation, we are going to consider another example on the commutative property. This should help you to be able to practice them more. So remember to have your jotter, to have your pen and your calculator so that you can write along. Now let's look at the question. So the question says that a binary operation star defined on the set of real numbers R by m operation n to be equal to m plus n all over 2nm. Now we have to determine whether or not the operation is commutative, and then we have to evaluate 3 operation minus 4. Now let's consider a solution for this question. So the question says that the operation is on m operation n to be equal to m plus n all over 2nm. Right. We can say that for commutativity, so in determining, we always have to write the rule. So commutativity, m operation n, because that's what has been given to us, m and n, is equal to n operation m, where m and n are a member of the real number system. Now let's consider the first part of the operation where we will look at m operation n. So that is what we have in the question. So we just have to write it out, m plus n all over 2nm. Now let's call this equation 1. And then we'll consider the other way around where we have n operation m. So that means that wherever we see m, we must put n there. And wherever we see n, we must put m there in the operation. So that becomes n plus m all over 2mn. Now let's call this equation 2. Now we want to compare equation 1. We want to compare equation 1 and equation 2. So we realize that for equation 1, the m is positive. Equation 2, the m is positive. We see that for equation 1, the n is positive. Equation 2, the n is positive. And then the division signs are at the same place. And then we have 2nm and 2mn. We know that multiplication is usually close or commutative when it comes to real numbers. So therefore, we can say that since equation 1 is equal to equation 2, then the operation star is commutative. So we can conclude that this operation is indeed commutative. So that is the A part of the question. Now let's consider how we can evaluate 3 operation negative 4. So the question given to us is that we should evaluate 3 operation negative 4. So we have our m operation n to be equal to m plus n all over 2nm. Now this implies that our 3 operation negative 4, wherever we see our m, we'll put our 3 there. And wherever we see our n, we'll put our negative 4 there in the operation here. So that implies that we can have 3 operation negative 4 to be equal to 3 plus minus 4 all over 2 multiplied by 3 multiplied by minus 4. Right. So it means that our 3 operation negative 4 will be equal to 3 plus minus 4 gives us negative 1. Then 2 multiplied by 3 gives us 6. 6 times 4 gives us 24. But then in this case, because of the negative, becomes negative 24. So therefore, we can have our 3 operation negative 4 to be equal to 1 over 24. The negatives will cancel out. Right. So that is our evaluation of 3 operation negative 4. So basically in this lesson, we've considered another example on the commutative property. This is to tell you that you must solve more examples so that you'll be able to become very used to how to work things when it comes to the commutative property. In our next lesson, we'll be looking at another interesting property, which is associative property of binary operation. See you in the next lesson.